Well, welcome. Good morning. Thank you for joining our webinar this morning, and we'll kick off our presentation at this moment. This is a webinar from Evoqua Water Technologies. We're going to be discussing a discharge and recycle compliance for metal-bearing wastewaters as our topic today. And our speakers, I'm Mark Korzenecki, and I'm one of our business development managers for Wastewater Ion Exchange. I've been with Evoqua for about 16 years and also in the hazardous waste and wastewater environmental service areas for the past few years. The main presenter is Chris Riley. He is our technical service director. He's been with Evoqua and our predecessor companies for about 26 years. He has degrees in chemical engineering and also in civil engineering too. Okay, and our agenda for today. The goals of this presentation, we're going to be introducing you to our some of our products and services, and the goal of that is to understand how these services can help meet your compliance and sustainability objectives. Our topics for today for discussion, we're going to give you a high-level overview of our company. We're going to talk about some specific applications and introduce those to you. Then we're going to talk about our wastewater ion exchange services in detail, talk a little bit about our Roseville, Minnesota RCRA Part B processing facility, where we do process our ion exchange resins and also more concentrated hazardous waste. We're going to go through a few select applications and talk about how we employ the treatment strategies for those, and also talk about a few specific case studies related to those applications. And at the end, we'll wrap that up. So who is Evoqua Water Technologies? We're a leading provider of water and wastewater solutions. We offer a wide portfolio of products and services across the industrial, municipal, and recreational sectors. We understand that water is a finite resource, and we believe there's power and purpose in combining the expertise together to maintain the resource so it's available for all going forward into the future. What are some of the main facts about Evoqua at a glance? We're comprised of about 100 plus companies that make up our legacy for quality and innovation. We've got about 200,000 installations worldwide in a wide range of markets and industries, across the world. And to that point, we have about 160 locations globally. And then specifically in the United States, we're within about 2 hours. 90% of our facilities are within about 90% of all the major population centers in the United States to allow us to service our customers quickly and promptly when they need that. The revenue last year for Evoqua was about $1.43 billion. So we were able to be successful in a challenging year. What are our core commitments? We have a few principles that we work on that bring us towards a shared vision, and that purpose is transforming water and enriching lives. Our vision to get there is we want to be the world's first choice for water solutions, and the steps we take to get there are our values. We want to do what's right through our integrity, sustainability, our commitment to today and tomorrow. We want to perform and deliver on what we promise and the solutions that we offer to our customers. And of course, the customers being our foundation of success. And specifically to today's presentation, Evoqua has a strong commitment to sustainability. We understand that water is a key resource, and it's keeping that water and maintaining that water well is a key to health and wellness for everybody. As part of that, our objectives in Evoqua have aligned with some of the objectives that the UN has put together for sustainability. So that is just part of our goal to be able to keep those commitments and be able to protect that resource. And now we'll turn this over to Chris Riley for the meat of the presentation.
Thank you, Mark. Good morning, folks. Glad that you could all be with us today. We're going to talk about wastewater ion exchange products and technology and all things about it, but we want to start by just taking a look at a few selected applications where the wastewater ion exchange technology is applicable. This is by no means an exhaustive list since it's only 3, but it just kind of gives you a flavor of how the technology can be applied and the types of waste streams that it can be applied to. First application we're going to look at involves hexavalent chromium, whether it's plating or coating involving hexavalent chromium. Chrome, in general, chrome plating is used to improve hardness and durability of parts. It's also used to improve the appearance. Think of a nice shiny chrome bumper. There are also chromate conversion coatings that are applied post plating, say post cadmium or zinc plating, for example, to improve corrosion protection, as well as to improve corrosion protection on aluminum parts prior to them being painted or coated. Along with the hexavalent chromium processes, you have electroplating itself, the deposition of that chromium layer. You have chromic acid anodizing, where you're using a chromic acid solution, dipping parts in, and those parts are forming, those aluminum parts are forming their own aluminum oxide layer for protection. And you have the chromating process itself, where you're depositing a hexavalent chromium film on top of the part, again, for corrosion protection mainly. Typical wastewater issues and concerns coming out of hexchrome type processes are, of course, contaminant metals, chrome, whether it be trivalent chrome, hexavalent chrome. If you're using it as a post-plate chromating process, you may end up with cadmium or zinc, for example, also in your wastewater, as well as iron and other heavy metals. In addition to the metals, there are pH concerns. Typically, these solutions are low pH type solutions, so you may have a pH concern with your wastewater. You may have organic concerns, typically captured in analyzing total organic carbon, or TOC. You can just have a total dissolved solids, TDS. How much dissolved ionic material is in the wastewater? That can also just be considered your concern. And as well as suspended solids, particulate matter that happens to get in the wastewater. And of course, there are hexavalent chromium substitutes out there. There has been a lot of work trying to eliminate the use of hexavalent chromium in a lot of processes, and some of those processes work well. They can present some challenges of their own for wastewater treatment. Second application we're going to talk about a bit later as well is that involved with printed circuit boards, both manufacturing and assembly. In the manufacturing side, you're talking about actually manufacturing the bare boards themselves, where you're laminating, the copper layers along with the non-conductive layers. And you're also talking populating, where you're taking that bare board and applying the components to it, the resistors, the CPU, things of that nature. And then soldering those components on. Processes that are involved with printed circuit board manufacturer, they can run the gamut of typical metal finishing type processes. If you're looking at just board populating, for example, where you're, again, putting the components on the board, soldering it, then you have to end up cleaning it. So typically cleaning is your only process involved with the populating processes. If you're getting into the PCB manufacturing, then again, you're looking at a whole host of metal finishing type of processes, such as acid cleaning and etching, alkaline cleaning as well, electroplating, electrolysis plating, as well as developing and stripping. Wastewater issues and concerns, again, your contaminant metals are forefront. Copper mainly, since copper is the main metal used in the manufacture of the boards themselves, but you have other metals that can be involved as well in different parts of the components. You may see nickel, lead, tin, precious metals such as gold and silver, as well as others. Again, pH, organic concerns, dissolved solids, and suspended solids can also be issues. Things to think about and things that can cause headaches from these types of processes would be complexing chemistries that you might find in cleaners and electrolysis baths. And what I mean by a complexing chemistry is a chemical component that can grab a hold of a metal and want to keep it in solution and make it resistant to wastewater treatment. The last process we'll talk about is cadmium electroplating. Cadmium is a very toxic metal, but from the standpoint of cadmium plating, it provides great improvement in corrosion protection, especially in saltwater environments. And it can also help on fasteners, threaded fasteners especially, as it improves the lubricity, as well as the electrical conductivity. So cadmium plating is still out there, especially in a lot of aerospace components, and it's going to be around for quite some time. Processes that are involved with cadmium plating, of course, there's the plating itself, which is cyanide based, but you also have pre and post plating type processes such as aqueous cleaning, acid pickling, and chromating post plate, as we discussed earlier on the hexchrome slide. Wastewater issues and concerns that pop up, of course, the contaminant metals, that's probably the obvious thing. Cadmium and chromium as well can pop up as far as chromating wastewaters that will contain some cadmium as well. One of the big contaminants, of course, with cadmium is cyanide. Cadmium cyanide plating itself has been around for forever. There have been a number of substitutes that have been tried. There are some that are out there that work. They can be finicky. So cad cyanide, again, as I mentioned before, is around. It'll be around for a bit, I'm sure. And again, you have pH concerns, organic, dissolved solids, as well as suspended solids. All right, let's talk a bit about wastewater ion exchange services, some of the background and products, for example. What is wastewater ion exchange? The service involves using media tank-based wastewater treatment systems. In other words, there are tanks of wastewater treatment media that are placed in a system in order to treat certain wastewaters. And typically when we're talking those wastewaters, we're talking inorganic contaminants or primarily regulated heavy metals. Wastewater ion exchange, you can use it to achieve regulatory compliance, to meet your discharge limits, or to recycle the water, to reduce your water consumption and meet whatever quality specifications are in place for the particular process. When the media is spent, and this is probably the difference with the service wastewater ion exchange model, when the media is spent, the whole vessel goes back to the local processing facility for handling. In other words, there's no on-site regeneration for you. There's no removal of spent media or rebedding of the same vessels for you folks. Wastewater ion exchange is used in both hazardous, as far as RCRA hazardous, hazardous and non-hazardous applications. Metals that come from the media, that are removed by the media on your site, are then recovered when they go back and are processed at the processing facility. So it's a green technology. It can help support your sustainability objectives as well. And there's a lot of technical support that goes with this. It's not just tanks that are supplied. There's treatability testing, obviously system specifications, servicing throughout the nationwide service network, as well as material, media, profiling, handling, and transportation. Well, some of the benefits that come from this, it's a simple solution, a service-based solution. Again, it's meant to minimize your involvement in your wastewater treatment system, minimize space, minimize the maintenance, and try to minimize the amount of on-site chemicals that you may have to inventory, as well as keep your capital outlay low. These types of systems can be specified and installed fairly quickly from initial eval to the actual installation, and they're easily modifiable. By the different tank sizes, you can easily scale up to different flow rates, or you can add different media if you have a different component that needs to be removed. So the products in general, the media tanks, again, you have ion exchange, various ion exchange resins and adsorptive media, and those are chosen to tailor to the particular contaminant that needs to be removed. Tanks are typically portable, anywhere from 1.2 up to 60 cubic foot, and there are larger fixed vessels available as well. But as you can see from a flow rate standpoint, wastewater ion exchange can handle from very low to very high flow rates. It just depends which tank types you use and how you configure them. Typical treatment range rule of thumb, up to 100 ppm of contaminants. It certainly can be used for more than that under the right circumstances. Typical treated effluent levels, anywhere from very, very low PPT, single-digit PPT, up into the double-digit ppb range. In addition to the media tanks themselves, which are the stars of the show, there is ancillary equipment that's typically available as well. Aquasaver lift stations, which are essentially pumping stations. They can be have pH adjustment, or they can be without pH adjustment. Of course, there's interconnecting hoses with sampling ports, pre and post filters, flow meters, quality lights, things of that nature. Everything that's needed to operate successfully a system such as that. When we look at the service vessel options, again, this is just a quick little rundown of the available options. There are actually more than this, but for the most part, most of the applications fall with these portable tanks. Again, anywhere from the 1.2 up to the 60 cubic foot vessels. And you can see there, they can each accommodate different flow rates. And of course, they could be run in series or parallel to accommodate multiple flow rates as well. And then again, there are large fixed vessels available too. Those are typically then rebedded on site. And when we go through the application engineering process, we're looking at not only what has to be removed, but how are we going to remove it, what types of tanks to use. And so we, of course, will use this, this menu of tanks to determine what we need to specify a system for you. I mentioned media, the ion exchange resin or the adsorptive media. The wastewater ion exchange business, we employ a number of different media that are tailored to attack different types of contaminants. This is just a listing that covers the majority of the contaminants that are treated with the wastewater ion exchange systems. You can see contaminants listed, applications where you typically can find those types of metals, and then the media codes that are used to attack these various metals. And you can see for example, with copper, there's a whole host of different media that could be applied. It just comes down to background chemistry and other conditions as well. And that's where the applications engineering process comes into play. In addition to the wastewater ion exchange media tanks, media as far as ion exchange resin or adsorptive media used for treatment, there's also wastewater capital equipment that's available. This would be geared more toward the traditional precipitation or conventional treatment approach. Again, it can be used, these types of processes can be used to remove a number of different metals, as well as do things just such as pH neutralization. All these products there are standard products, so they're meant to be just pieced together to put together a complete system. Various equipment available, again, neutralization, precipitation, oxidation, cyanide destruction, a number of things. Of course, wastewater reverse osmosis when you get into water recovery. The ubiquitous and famous J-press, of course, for solids separation as well. When we're talking the capital equipment, we're typically talking more concentrated solutions. So again, rule of thumb, over 100 ppm doesn't mean you can't use capital equipment for lower concentrations. You certainly can, but just as a rule of thumb, the more concentrated, the more you probably are going to look at conventional type equipment. Conventional equipment, precipitation technologies, they do have a more limited range when it comes to achievable effluent levels. Typically, you're talking in the fractions of a part per million range for treated effluent levels. So we've talked a bit about the products themselves. Let's talk about the actual processing facility located in Roseville, Minnesota. The processing facility in Roseville is actually a RCRA, which is Resource Conservation Recovery Act. The RCRA governs all hazardous waste regulations and rules. It's a RCRA Part B permitted treatment, storage, and disposal facility. And the facility processes both hazardous and non-hazardous bulk inorganic wastewaters, as well as ion exchange resins and adsorptive media. The facility was purpose-built. It was specifically built for this function. Back in the late 80s, 1988 is when it opened up. And it was specifically engineered for these types of activities. In other words, specific containment was engineered into the facility, as well as emergency systems and everything that you might need for the treatment of both hazardous and non-hazardous wastes in a compliant and safe manner. Typical RCRA hazardous waste codes accepted for hazardous waste would include your typical metal finishing waste codes, some of the F codes shown there. The D codes, certainly the RCRA 8 metals, plus things that may be reactive, such as oxidizers as well as corrosives. And P and U codes, which are typically discarded material, if you will, commercial material, chemicals. Those types of waste also are taken in on a case-by-case basis. What does the facility do? Mainly ion exchange resin regeneration with residuals recovery, as well as, in addition to, ion exchange resin, we also supply absorptive media for certain applications, and of course that media is handled there too, whether that's typically rebedded and also then sent off for recovery. The facility also treats bulk metal-bearing wastewater treatment, or bulk metal-bearing wastewater. So picture regenerant from ion exchange activities and or bulk wastewaters that come directly from customers, say bulk acids, caustics, cyanides, chrome-containing solutions. All that is done in that facility. And there's also waste consolidation and transfer. For example, the facility will accept customer-generated residuals or sludges and then bulk them up for offsite shipment for recovery. Housed in this facility also is the applications laboratory for the wastewater ion exchange business. The lab does a number of different things, provides a lot of, let's call it standard and specialized analyses to support the wastewater ion exchange as well as the bulk wastewater receiving business. So a lot of different analyses or analytical capabilities are listed there. And those are all quite standard for most samples that come in to the facility for evaluation. In addition to that analytical testing, we do other things as well that are relevant to wastewater ion exchange, such as filter studies. In other words, we're looking at what kind of solids are in particular wastewaters and what sizes they are. Wastewater ion exchange, whether it's resin or adsorptive media, that's meant to remove dissolved contaminants, dissolved copper, for example. Suspended copper or particulate copper is not going to be removed by the resin. Well, it may be, you'd prefer it not be, because particles that get inside the media beds can eventually come out. They will find their way out. So you want to remove those through filtration means. So we'll use these filter studies to determine what's in there, what type of particulate is in there, what size it is, what filters are needed to support the wastewater ion exchange resin and or media. We'll do bench scale media treatment testing as well, whether it's short-term, just to confirm removal efficiencies of various contaminants, or long-term testing that'll actually run small columns through to breakthrough to get a better idea of throughput. Going along with that, of course, we supply a lot of media, so there's a lot of media QC and troubleshooting activities that are done in the laboratory as well. The facility and the wastewater ion exchange business, it's meant to help our customers with their waste management activities. Of course, there's cradle to grave management where generators are responsible for all aspects of managing their waste, from generation to disposal and all the documentation that goes on in between. And we're here to help. That facility in Roseville and the folks there are there to help with some of those activities, with characterization activities, with transportation, of course, with treatment and disposal, and also with documentation. Again, it is the customer's responsibility per the RCRA regulations, but we are there to help with all those activities to make it easier for you folks in your waste management activities. Evoqua also assumes title to these any conforming waste that comes into the facility. Evoqua then assumes title to that waste. Any residuals that end up going off are shipped off as Evoqua waste, right? Certainly, if we're regenerating ion exchange resin and we generate sludge, that's an Evoqua waste. But media that's brought in, say single-use media or sludges that come into us, they end up leaving the facility as an Evoqua waste. So it helps minimize your risk. It doesn't eliminate it, but it does help minimize it. Again, this would be treatment residuals from regeneration, which would be metal-containing sludges typically, single-use spent media, as well as any residuals from bulk wastewater treatment. When I talk waste residuals recovery, or the recovery of metals and things of that nature that emanate from the Roseville facility, basically we're talking about those sludges. Again, sludges that are generated from regeneration, or sludges that are brought into our facility, or single-use media that are brought back to our facility. So these residuals go off-site. They're recovered at several facilities across the US, and typically it's a metal refining, high temperature type process. Again, these are customer and Avoca generated residuals. So if you as a customer send us some wastewater treatment sludge, it'll go off for recovery as well. There are high temperature refining processes that'll recover a number of different metals. The leftover material, which is typically an iron-rich material, then goes in as a feedstock for high-density Portland cement. So essentially nothing to landfill for the materials that go off-site for recovery. So this management program for residuals results in over 99% of all the metals received going off for recovery, which minimizes your risk by avoiding having these materials go into a landfill. Just a quick look at numbers here. In 2020, for example, about 4.5 million pounds in total of metal solids were sent off-site for recovery from the facility. All right, we're going to walk through these selected applications again and talk about some treatment strategies. If you recall, we talked about hexavalent chrome plating and related processes. In other words, chrome plating, whether it be hard chrome plating, decorative chrome plating, or chromating in general. We talked about the issues and concerns ranging from the metals to pH and other things, as well as some challenges that might be caused by some of the substitutes that are out there. Treatment strategies are fairly straightforward, actually. If you're looking at reuse, for example, of these types of wastewaters, you want to remove the total dissolved solids. Basically, you want to remove all of the ionic contamination that's in there to allow reuse of that wastewater, either within the process itself or somewhere else within the facility. In addition to the dissolved solids, typically you're looking at removal of TOC, or total organic carbon, at the same time. If we're looking at waste discharge, or just discharge to the POTW, for example, or the industrial sewer, we're usually then looking at specific target contaminants for removal. Looking at wastewater ion exchange, the media tanks that we talked about, we're looking at either metals for compliance or TDS for recovery, looking at the removal of those components. So there's a diagram there. It's a simple diagram of a simple system for wastewater ion exchange treatment of a hexchrome type wastewater. You have ion exchange resins. Again, the resins shown there, that is a recycle type setup. A discharge setup would be similar. It might use a lesser amount of resin tanks, but it would look fairly similar. You have ion exchange resins themselves in the tanks. You'll typically have filtration in reuse type situation, pre-filtration and post-filtration. In a discharge situation, you may only require pre-filtration. In this particular case, for recycle, we've got quality lights, or you could use conductivity or resistivity monitors to monitor that recovered water quality. If you're looking at a discharge situation, in that case, you're going to be sampling and analyzing for individual target contaminants, just to ensure that you're meeting compliance needs. Mentioned before, capital equipment for chrome type wastewater. Capital equipment available would be some type of chrome reduction system, where you're taking the hex chrome and turning it into trichrome, and then a precipitation system to drop out that trichrome as a chrome solid, and means to separate it via clarifier or microfilter, and then a filter press, typically to dewater. You may also then need a neutralization system to adjust pH. If you're talking wastewater recovery in this case, in addition to wastewater ion exchange media, there's the possibility of wastewater reverse osmosis for water recovery. Quick look at a case study from the aerospace industry. there was a manufacturer of aircraft structures. And they were doing chromate on aluminum, a very common process. There had been some exceedances in their discharge to the city. Local POTW had some issues with that. So the customer wanted to obviously do a couple things. First and foremost, achieve compliance to eliminate those fines. And at the same time, use less water if that was possible. So in this particular situation, there were a number of wastewater sources that were contributing to the overall wastewater. So in the applications lab, we evaluated samples of all the wastewaters following chromate process as well as other steps. And from that evaluation, we were able to identify several rinses which could be successfully recycled. Now, not all rinses can be recycled, or certainly not all economically recycled. So that's why we like to take a look at what's going into a particular wastewater. To, if nothing else, you go for the low-hanging fruit, find the stuff that's easily recyclable. In this case, we installed just a small 10 GPM demonstration system that would use small 3.6 cubic foot FRP tanks. Put in this system on the recommended rinses to essentially try it out, see how it works. And it works very effectively in meeting the goals. So from that small system, we went to a 60 cubic foot permanent system using cation and anion exchange resins. And an example of that would be shown in the photo there. And that recycles up to 150 GPM of their chrome-bearing rinse waters. So that first and foremost got them in compliance, eliminated any fine issues, but also secondary, but as important, it allowed them to reuse water, which of course reduced any incoming water usage as well as improve the quality of the rinse water used to rinse. Looking at circuit board manufacturing and populating, again, the process is listed there. The wastewater issues and concerns, again, a number of metals, pH, other things, organics, dissolved solids, suspended solids, complex in chemistry, which can be kind of a problem. Treatment strategy, very similar, if not identical, to the other process we just spoke about. You're either trying to take out all the dissolved solids, all the ionic contamination for NTOC for reuse, or you're trying to take out target contaminants to just maintain some sort of discharge compliance. Again, this may look very familiar, except for the diagram looks a bit different, but you're looking at ion exchange resins in this case for recycle or reuse, or to meet the discharge requirement, depending on what the end goal is. Same thing, filtration pre and post to remove those suspended solids. Again, you don't want suspended solids in your ion exchange media tanks because they can be the gift that keeps on giving and just cause problems down the line. So adequate and proper filtration is required. Quality light, again, conductivity resistivity meters to measure recovered water quality, or, again, individual sampling of target contaminants. In this case, the particular diagram shows a small carbon and mixed bed type system that's used for recovery of wastewaters. This would be something you would probably see on a printed circuit board populating application where you're treating an aqueous cleaning rinse, for example. Depending on all, what's in that wastewater, again, you could be looking at capital equipment as well if you've got some higher concentration type wastewater. In this case, precipitation, solid separation, and solids dewatering are probably going to be your three main components. There's also, again, pH adjustment, neutralization systems available, as well as the possibility of water recycling through a wastewater reverse osmosis system. All right, we are looking at, in this case, from in aerospace, another aerospace application would be a PCB manufacturer that was located on the West Coast. They are having some issues with water supply. A lot of drought conditions out that way, and was causing some water shortages. And the ability to get enough water for their process was adversely affecting their ability to produce their parts. So they wanted to reduce their water consumption at the same time, supply some high quality water that are typical in PCB manufacturing operations. Similar to the previous application, We evaluated a sample of the wastewaters in the applications lab, looking at both treatment and recovery potential. We identified the PCB populating rinses that could be successfully recycled, again, the low-hanging fruit as it will. We installed a small 3.6 cubic foot vessel system there using carbon and mixed bed. And that was used to treat and recycle up to 10 GPM of this wastewater. This reduced their incoming water usage, eliminated that adverse production impact because now they didn't have water supply issues, and at the same time, improved the quality of the water used to rinse their populated printed circuit boards. So it was a nice solution for them. Looking at cadmium electroplating, again, we talked about CAD plating and all the various processes that go along with it, as well as the wastewater concerns and treatment strategies. Again, same thing, removal of those dissolved solids for reuse plus TOC or removal of target contaminants. What makes things a little different with cadmium electroplating is the presence of cyanide. That cyanide is there to complex cadmium, does a very good job at that. It also can make wastewaters resistant to effective treatment by keeping that cadmium in solution. So you have to account for that, whether you're looking at wastewater ion exchange media or conventional type solution. In this particular case, again, ion exchange resins can be used for recycle or to meet discharge compliance. In this case, we used a couple of tanks of specific resin that were able to treat the wastewater and remove both the cadmium and the cyanide. Filtration is again part of that, usually most always pre-filtration in a discharge scenario, sometimes post-filtration depending on what we find in our evaluation in the laboratory. Quality lights, again, connectivity resistivity meters to monitor your recovered water quality. And in this case, you'd be looking at monitoring for both cadmium and cyanide, individual target contaminants. If you're looking at discharge compliance. Capital equipment that could be used would be similar to what we just saw in the PCB and chrome applications with the addition of the cyanide oxidation module. Again, I mentioned cyanide holds on to cadmium, keeps it in solution. It's a complexer. So it complexes cadmium, and you need to break that cyanide cadmium bond in order to allow the cadmium to be removed by conventional means, by precipitation. So a cyanide oxidation module would be used, followed by precipitation, solid separation, and solids dewatering. Also, of course, again, neutralization systems, as well as the potential for recycling via wastewater reverse osmosis. Looking at this case study here, another aerospace application where a firm had to bring some manufacturing in-house to help their cost situation, improve profitability. So they had to install a new CAD cyanide electroplating process. And the existing wastewater treatment system in place at the time was not capable of treating wastewaters from this process. So they needed to move quickly, do something quickly, add the ability to treat for cadmium and cyanide. So we looked at the chemistries, the wastewaters, the chemistries that are intended to be used in this new process because the process didn't exist at the time, right? So we were able to review the chemistries that were going to be used. And based on what the customer initially wanted, we proposed a conventional cyanide destruct system, which would be alkaline chlorination, essentially using bleach to destroy the cyanide and free up the cadmium so it could be precipitated. So that was the initial proposal. After looking at costs and lead time and CapEx requirements, customer and we decided on an alternate design that was involved wastewater ion exchange. It installed ultimately a 30 cubic foot vessel system, uses an ion exchange resin to treat 75 GPM of this wastewater. The resin has the nice ability to remove both cadmium as well as cadmium cyanide complexes. So it was a nice all-in-one type of solution, if you will. When it comes to cyanide in general and cyanide treatment processes, wastewater ion exchange can be used as a standalone system. It can also be used as an adjunct to an existing alkaline chlorination system, for example. You may want to look at using wastewater ion exchange to remove, in this case, cadmium cyanide complexes before they get to the cyanide destruct system, so that the destruct system can just concentrate on treating free cyanide and let the resin concentrate on treating the metal cyanide complex. So there's a number of different ways IX could be involved. Wastewater ion exchange could be involved with the cyanide type system. This particular system, most importantly, met the facility discharge compliance goal. Introduced no hazardous or additional hazardous chemicals to the facility, chemicals that would be required for precipitation, and it did meet the customer's timeline. One thing I also wanted to mention, I started to allude to it, was in addition to treating wastewaters directly, wastewater ion exchange is also an excellent technology for polishing from an existing wastewater treatment process. If you have an existing conventional precipitation type system, you can easily use wastewater ion exchange on the end of that system for further polishing. In these types of cases, you typically use a selective resin or a selective adsorptive media, one that doesn't take out everything, but just tries to take out whatever target contaminant is causing a problem. Similar to the other systems, you'd have filtration typically in this case, and then you'd be sampling the water along the way through the system to monitor the individual target contaminants. And you could also investigate wastewater recovery, or excuse me, wastewater reverse osmosis for recovery of the wastewater treatment effluent. Obviously, from the wastewater treatment processes, that water can be rather high in TDS, rather salty, but it can be done under the right circumstances. Taking a look at a specific case for that, there was a metal finishing job shop, essentially generating metal-bearing wastewaters, and they had their own treatment system in place, a conventional treatment system in place, which met most of their limits, but they would have occasional but regular spikes in cadmium that resulted in some fines and some unwanted public exposure. The Evoqua solution, we evaluated samples again of this wastewater effluent to try to see what does it look like when these spikes are occurring. And we looked at some media treatability and filtration studies because in this particular case, especially with wastewater treatment effluent, you're talking a lot of times particulate metals being involved as well. We determined the appropriate media to achieve the low cadmium limits, and identified also, most importantly, or as important, the proper filtration to remove the particulate form of the cadmium that was sneaking through as well. Ultimately, in the end, a 50 GPM polishing system was installed. It involved 30 cubic foot vessels, like you see in the photo there, as well as filtration. This allowed them to, to meet their discharge limit, which was the paramount concern, eliminate fines, and allowed them just to focus on their manufacturing process. And now I'm going to turn it back to Mark for some closing remarks.
All right, well, thank you, Chris. And just to recap our presentation today before we go into some of the questions that have been asked, I just want to give you a summary. Hopefully you've seen through the presentation, we've demonstrated a few different ways that Evoqua's technologies and service offering can help meet some of your sustainability and compliance goals. Some of the unique ways that we do offer those benefits, some we've touched on already, some of these are new, but we do assist our generators, our waste generators, with compliance. And that's through the initial waste characterization. We help with all logistics regarding the shipment of the hazardous tanks back to our facility. That's through placarding and manifesting and making the arrangements with the necessary transporter to do that. We help waste generators enhance sustainability by recovering the majority of the metals that come to us on the spent resins and the media when they get back to ROSO. As Chris alluded to, we do recover almost all the spent metal residuals that come back to our facility. We also take title to the conforming waste once we receive the exhausted media tank back at Roseville. And just some of the additional customer benefits that we can offer. The wastewater ion exchange systems do offer a significant reduction of labor versus the more standard or conventional treatment technologies which are out there, which we do offer. But in the situations, the many situations where wastewater ion exchange services are appropriate, it allows the customer to focus on their core business and kind of outsource that wastewater treatment portion to our easily exchangeable service vessels. We've got a short lead time to implement the system. It could be as little as 2 weeks if a customer needs to get that in and installed quickly to either bring somebody back into compliance or for recycling water. We can do that in short order. One of the other benefits that we do, the ion exchange provides, is removing handling and safety concerns by eliminating the need for unloading and loading and filling and unfilling resin tanks on site. All of those activities are removed, and they're brought back to our Evoqua facility in Minnesota by removing those entire tanks when they're spent and shipping them off for final treatment. And one of the final benefit here is reducing the treatment system footprint. Compared to most other alternative technologies, the actual vessel size footprint is much more compact and able to allow more space to be freed up for the core activities that you have as a business. So where can we go to learn to find out about some more of our services? The main way here is through our website at evoqua.com, wastewater ion exchange landing page. And that will provide a wealth of information on our particular products, the case studies, documentation, and things like that. And through that portal too, you'll be able to request proposal or request one of our account managers, outside sales folks, to reach out to you and answer any of your questions. So we thank you for joining our webinar, our presentation on compliance and meeting sustainability goals.
And same for me. This is Chris. Thank you very much for joining us for this, and take care now.